the major role in people, like Newton and Faraday. Faraday himself felt that the electric force would explain gravity eventually, and he said it would be a breakthrough of, unimaginable scope.
Mm-hmm.
And I think he's quite right. The way I came to it was reading Velikovsky's Wells in Collision, exactly the same as with David Talbot. Only I was lucky because before I entered university, I read that book, and that inspired me to follow it up. So when I was at university, I was I think I was the only science undergraduate who was in the shelves of the anthropology section, just pulling books at random off the shelf and reading the stories of, the most ancient peoples on Earth.
Mm-hmm.
The stories just leapt off the page at me looking at it from Velikovsky's point of view, which is that the solar system does have a recent history, and that all of the reverence for planetary gods for the earliest civilizations was real. They weren't just making stories up. The stories were about the activities of planets.
Mm-hmm.
So I managed to complete my degree and go on. I began postgraduate work, but by asking questions, I was getting hostility. I wasn't getting the answers I was satisfied with.
Mm.
So I decided that academia was no place for somebody who had heretical ideas, and so I left and joined the computing fraternity with IBM first and then the Australian government. And when I was with the Australian government, I took the opportunity, because I'd travelled the world many times, to meet up with people who I felt had parts of the puzzle. And that included Velikovsky himself.
Mm-hmm.
And that was an important meeting because he very kindly accepted me and my family, with 3 daughters, and my wife, at his home in Princeton.
Wow.
It was only 6 months before he died. And, of course, he would have had no idea that I might pick up the baton that he was to drop shortly after. And I was unaware of that fact too. But the question I put to him was that because the major argument against him was merely one of stating that his work disobeyed Newton's laws, what was it that we didn't understand about gravity?
Yes.
He had actually thought about that and written about it, but he didn't want it broadcast because he had reservations about it. And in fact, the basic idea, I think, came from one of his daughters. But it basically boiled down to the fact that normal matter, the matter that makes up you and I and everything around us, is made up of neutral atoms. If they weren't, we'd all be electrically charged and be zapping everything we touched. But these neutral atoms themselves are made up of electrical particles, positive and negative, and they can't occupy the same space at the same time. This means that you can actually have atoms slightly distorted by their surroundings, by nearby atoms and the Earth itself. And when they're distorted, they form tiny electric dipoles, which are electrically neutral. However, they do produce an electric force.
Mm-hmm.
And it was that he said explained how you can hold billions of tons of water in the atmosphere against the force of gravity, because water droplets, very small ones, are much heavier than the air around them. And he said it's because they are dipolar molecules. In other words, they form tiny little electric dipoles. And in the Earth's electric field, that defies gravity, and so that's why you can have those huge thunderstorms that dump billions of tons of water on you in a few minutes. That too is an electrical effect. In other words, the lightning discharges some of that electricity, and all of a sudden you've got a downpour. So all of these things made sense to me. It was only 2 years later, there was a tiny advertisement in the Scientific American. It was called the Journal of Classical Physics, and the very first article talked about the structure of the electron. Now, this is an idea that particle physicists haven't cottoned onto. They think the electron is a fundamental particle. Mm-hmm. But this guy decided that no, it was a repeated pattern. It was just all particles are made up of orbiting systems of charge. And when you do that, all of a sudden, you have an explanation for both magnetism and gravity. Now, with all of these kinds of simple ideas in mind, it was possible then to look at the work that David Talbot had done, which was quite incredible, really. He spent decades on that, and I spent decades coming from another angle, and we met up finally in 1994 when I rang him in Portland, Oregon, and said, somebody here wants a copy of your book, The Saturn Myth. And he said, well, it's out of print. I told him what I was doing, and he said, oh, have you got something you'd like to present? Well, I'm putting on the first international conference here in Portland. And I said, yes, I have, because I'd been spending some years in England with a group over there who were involved in post-Velikovskian studies, if you like. And I was friends with some of the people working on the scientific aspects. And it was there when I saw what Dave had done, I realised immediately what he was showing were electrical effects between planets, because he was showing Venus in relationship to the Earth and so on. I caught up with him and I said, you may not remember me, but 20 years ago we met at the conference in Hamilton, Ontario. It was the first international Velikovsky meeting. And I'd been invited to that by David's brother, as it turns out. So I said to him, I've seen your work. I think our combined story is far more powerful than either of us trying to work alone, me on the science and you on the reconstruction of the past history of the Earth. And I managed to convince him of that a year or so later when I camped on his office floor for a month in December while the water dripped outside incessantly. And we put on an international meeting in January 1997, it was. And that was the start of the collaboration. Nice. And we thought it would take off very quickly, but it's taken an awful lot of work since then. And I think it was not the time. It certainly wasn't the time. But now we've become, as Dave says, a movement, because qualified scientists and engineers and all sorts of people in all different disciplines are joining us, because this is a science which has no boundaries. You can cross disciplines easily because you can see the connections. Once you have a big picture of how things seem to work, everyone can understand it, then they can see what their role could be in furthering what we're doing. And that's one of the most exciting things about it now, that we're actually doing a multi-million-dollar experiment in Canada to show that the sun is not what we think it is. And this all boils down to the fact that if the universe is driven electrically, then stars are not thermonuclear gravitational bodies. In fact, when you look at the idea, you realise just how desperate it was. It was a desperate attempt by scientists a century ago to explain how the sun could keep shining for so long without running out of fuel, because it was viewed as like a fire in the sky, the old campfire in the sky idea, that it had to be self-sufficient. But the electric universe is one of connectivity. Everything is connected. And in the case of stars, they're connected to the galaxy itself by electrical filaments, which connect everything. And they've only just begun to discover them. Radio astronomers have known about them for a while, but the establishment was unwilling to give any credence to the data that had been collected and been analysed by one radio astronomer in particular, Gerard Verschuur, who showed that they could only be explained in terms of plasma, electrical plasma effects. That hasn't yet seeped in. They've found that there are these filaments connecting stars in the galaxy and locally, and they've discovered that the boundary of the sun with the galaxy is odd. It wasn't what they expected. It fitted none of the theories. I think there were about 18 different theories at the time, and not one of them matched, except mine. So this is just sort of an outline of what the electric universe is about. It's about simplification, which is what the scientists of the 19th century were all about. We lost that in the 20th century when we entered an age of neo-Pythagorean, the Pythagoras idea of that you can explain everything in terms of geometry. That's why where Einstein went with his idea of warp space and so on. But that is a dead end, because it describes things. Mathematics can describe things, and it's very powerful. It's very useful. But it can't explain things. So you've got to have the correct ideas in place first and then apply the mathematics, and then it's really powerful. because you can see new ways of looking at things and get information that you would otherwise be inaccessible just by observation. So, I went on a bit, I'm afraid, but
No.
it's like the old exam question, you have 1 hour, describe the universe and give another example.
Well said. Yeah, I am so curious about it. I do like everything I hear. And I guess a lot of people might be surprised to realize that a lot of things they might consider to be, quote, settled science actually are just kind of ideas that really haven't been backed up in a lot of cases. And I guess I would ask you, what holes are there in the conventional model that the electric universe model fills in?
I should say to begin with that there is no such thing as settled science.
Right.
It's an oxymoron. The electric universe uses quite heavily the peer-reviewed work of plasma cosmologists. And plasma cosmologists have been working in the laboratory for decades, since almost a century ago, looking at the effects of electrical discharges in a very thin gas, or the vacuum of space, if you like. And they were able to show that you can explain galaxies, spiral galaxies, their shape, their rotation, and so on, without even using gravity. When they put gravity into the mix, it made no difference. So it shows you that galaxies at that scale, the electromagnetic forces of the electric currents flowing through the universe dominate. So you can forget about gravity. And that's why the gravitational theorists had to invent dark matter to make up the deficit in their model. The deficit is there because the concepts that underpin it are invalid. So the question then is, well, what's this huge concentration of mass at the centre of a galaxy if it's not a black hole? Well, one of our team here, Steve Crothers, another Australian, has shown that the theory of black holes is actually full of mathematical holes. A lot of meaningless terms are involved. And this is one of the dangers. You look at a blackboard full of mathematical symbols. Unless the lecturer can explain each of those symbols in physical terms, then there's no necessity to believe anything that comes out of that, all those equations. So the plasma cosmologists show that the spiral arms of a galaxy are due to what's known as a plasma pinch effect. And that is when the currents, I should say, flow through the universe like twisted pairs. Now, engineers know that a twisted pair of wires is the most efficient way of transferring energy down two wires without loss. And the universe was there first. They did it. I mean, the universe did it. It knows how to do it. Nature never does things the hard way. Now, when two of those filaments, they're huge, by the way, when two of them come close to one another, they interact magnetically and draw each other together until they go into a dance, if you like, around one another, and they pinch together, and electric currents flow from depending on which way you look at current flow, the electron flows goes from the outside to the inside. And so at the centers of galaxies, there's not a black hole. There is a thing called a plasma focus, a dense plasma focus. It's where the plasma is densest, and this is where you get all of these effects which look like a massive object. However, Einstein, or the equation that is attributed to Einstein, E equals mc squared, the one that everyone knows and nobody understands, says that energy and mass are equivalent. Now, in the dense plasma focus, you have a thing shaped like a donut where the electric currents are twisted as tightly as you can imagine around one another, and that's because of all the energy stored in that tiny little thing. It appears extremely massive, and its effect on the bodies around it appears though it's extremely massive. Another aspect of these that the engineers know that worked on these plasma focuses, and it's the sort of thing there's even a guy here in Canberra had one in his garage. He was a high voltage engineer. He said, oh, they're very easy to build. Anyway, this tiny little donut becomes unstable at some point, and it ejects jets along the axis. And this is exactly what we see galaxies doing, and exactly what black holes shouldn't be doing, since they're supposed to suck everything in.
Right.
So the evidence is just staring us in the face that the gravitational model of galaxies is incorrect. But this comes down then to the human aspect in science. And because of the specialization, the way we train people these days, their ability to see the big picture is actually disabled. It's this concentration on detail, like a chicken pecking for seeds amongst the dirt. This concentration on detail that doesn't allow them to see the big picture.
Right.
And as a well-known psychiatrist said, this kind of left brain thinking is the kind that is required for survival on the part of the chicken, but it's the right hemisphere which has a global, keeps an eye out so that the chicken doesn't become somebody else's dinner. Well, it seems that the way we educate students these days in mathematics and that gives them the left hemisphere dominance, which inhibits this ability to actually see what's right in front of them.
Right.
So, we have to change our ways. We have to change the way we train people. The old classical model of education where you did a bit of everything, you did the arts as well as the sciences, is actually the kind of thing that I think we have to return to. And I think a lot of students would be happy with that too.
I agree, yeah. Separating everything has really set us back in a lot of ways.
Yes.
And in one of your presentations, you say that the solar nebula model has no successful predictions to its name. And that sounds like a pretty bold statement. What exactly do you mean by that?
What I mean is it's never been shown how you form a single planet in the vastness of space from a disk. You imagine where the Earth is now, that there's a disk of dust and gas that stretches right around the sun in our orbit. There is no real way to make that dust coalesce to form a single planet. Mm-hmm. And I attend astrophysics seminars at the research school here at the National University, and we had an expert on the solar system and the planets and planetary formation, and he admitted that you need a different theory for every planet. Now, this shows that the model that they use, that gravitational accretion model, is in serious doubt, but this is not admitted. What happens is that people then, using the left hemisphere approach again, the left brain approach, they go in front of their computers and they build models and try and make it work. And they can make all kinds of assumptions. It doesn't matter. They just add more and more variables. And this is one reason why the Big Bang model has more variables than it has actually information. In other words, it's a failing paradigm. Mm-hmm. Now, with the planets, the thing is that when the infrared telescopes in space began to peer into the clouds in deep space where stars are forming, they were surprised to find that they're forming in strings, like beads on a string. Now, this is precisely what the plasma cosmologist said would happen, because stars form rather like the galaxy forms in pinches along these electrical currents through the cloud. So if you like, you can imagine lightning in an earthly cloud. Well, lightning can form a bead lightning if it's sufficiently powerful. Mm-hmm. That means you get little bright blobs where the channel breaks up. And this appears to be what happens in those molecular clouds in deep space. Now, there is no reason at all to suggest that only stars are formed in that pinch. Any bodies down to any size can form in that same event. And this is precisely the electric universe model. Once the lightning fades, if you like to put it that way, gravity then does begin to take over, and these bodies then assume partnerships. And this is why the solar system looks like a fruit salad. There is no gradation of properties from the inside to the outside. They're all individuals, if you like. We're like a blended family.
Right.
And this is important from the view of David Talbot's reconstruction of the recent history of the solar system, and also the incredible amount of research and documentation that's been done by one of our colleagues, Eduardo Cardona, in his Star series of books. And if you want to know what the recent history of the solar system and the Earth and humanity was really all about, I would recommend that you begin to read Eduardo Cardona's books. They're very readable, heavily documented if you want to chase things up, and they make sense. And it was his work that I used as a basis for trying to explain using the physics of the electric universe, because I felt that if I couldn't do that, then we're in real trouble. And I finally managed to do that just a few years ago. I mean, it took that long to figure out how you could actually form the strange things that were recorded and memorized and memorialized by the ancients. It's a picture which out science fiction's any science fiction story, but it can be supported both scientifically now and through the mytho-historical reconstructions.
Right. I definitely want to get into the radically different history of our own solar system as described in this paradigm, because it is so different than what we're typically told. But I'm curious, talking about the way that planets form, that they are formed somewhat suddenly and violently from larger bodies rather than slowly formed over millions of years. Has a planet birthing, as described in the electric universe model, ever been observed?
Well, one of the things that we observe with our own sun is that it can eject billions of tons of matter in these coronal mass ejection events, they call them, and at very high velocity. So it's not true that you can't form objects by one giving birth to another. And in the electrical model of stars, this is actually what we expect. One of the reasons why stars have a cutoff in size. The other aspect is that when we look out into space and we look at other planetary systems and we see stars with rings of dust around them, we assume that that is gravitational accretion. Mm-hmm. The electric universe says no, that is actually the result of that star having expelled material, and it goes into orbit about it. Now, in the process of expulsion, the forces involved generally give you a backing up of the material so that you'll form one large object or maybe a couple of fairly large objects, and they'll be embedded in a ring of dust initially. And also we have the record of the ancients and their description of the birth of Venus. And of course, Venus is a very hot object, as if it had been born from a body, from the bulk of the body.
Right.
This fits the electrical model that when a star suffers a sudden change in its electrical environment, it has to adjust. And the best way of adjusting is to get rid of charge, and that charge is in the form of matter, the actual material of the star itself. And so that's what it is. An electrical discharge removes that material. A bit like an arc welder you can weld against gravity. You can weld uphill if you like. Sorry about that.
No worries. We were talking about Venus, and I was going to say Venus is an interesting body in this paradigm because it seems like, according to the electric universe model, it's the youngest body in our solar system. And also, I guess, I've heard you talk about some type of charge that can be detected between Venus and the Earth, if I'm not mistaken.
Yes, that's right. Venus, when these objects are born from ejected from a star, the initial effect is rather like two gears meshing, and you imagine, in this case, we're talking about proto-Saturn, as we call it, the brown dwarf star that became the planet Saturn.
Right.
In the process of adjusting to its new electrical environment within the sun's electrical neighborhood, it had suddenly to change from being a star to being what it was in effect, a giant comet. And comets, we know, spit material out. This is part of the electrical discharge effect. And it was dramatic in the case of Saturn, because here you've got two stars fighting over its power supply. And Saturn, of course, lost because it was the smaller body. Now, when this body is ejected, it has a slight backward kick, and this explains why Venus has this retrograde rotation. Also, it explains its great heat. I mean, what do they say, 800 degrees Fahrenheit or something at the surface. It's enough to melt some metals. Also, it has a young surface. Now, the standard idea was, the resurfacing event must have occurred. And the latest one is, it must have been hit by some large body and everything melted. These are just ad hoc stories with nothing to back them up at all. just a story to try and cover up the cracks in the actual model itself. But all of the facts fit. And also around Venus, you've got this equatorial belt of filamentary scars, which were recorded by the Magellan orbiter with its radar. And those scars are exactly the kind of phenomena you see in an electrical discharge. They're called Lichtenberg figures, the kind of things you see on a golf green where lightning has struck the flag and spread across the grass. It's that sort of spidery effect. And in a thick atmosphere like Venus has got, that's precisely what would happen to any lightning. It would split up into long, thin filamentary streaks. And they stretch around the equator, which is where you would expect the main discharge to have struck. So all of the evidence is right there.
Right. Yeah, I love this stuff. And how does this model of planet birthing relate to planet composition? Because we're told of how they're formed in gravity. A planet gets denser and denser towards its core. Might this be different in any significant way?
Well, if we go back to what I was talking about, the birth of stars and planets in a molecular cloud, one of the very interesting effects that you get in that kind of accretion of a body is that the elements are sorted by their electrical nature and the fact that it is an electrical or electromagnetic event. And you get all the heavy elements at the center, and they're cool, by the way. They're not hot. And they radiate their energy away as it's accreting. And you get the lightest elements like hydrogen and helium at the outside. So that becomes the atmosphere of a large body, or oxygen, nitrogen, and things like that for smaller bodies. So this also tells us that stars do not have hydrogen at their center. I mean, it's a crazy idea when you think about it, that the lightest element there is would be at the core of a heavy body, like a star. It's just not so. The heavy elements are all there. They're made just like planets. And this is why when you look at a sunspot, it's dark beneath that glowing plasma sheath. That's all it is. It's the sun's like a ball of lightning, and we see the light tops of the lightning, which is that granular effect. And where it clears, in other words, the discharge goes straight through from above down through that to lower levels. It's darker down there. And you can actually see in some of the best telescopic views that inside that black sunspot is brighter, smaller dots. In other words, that's where it becomes more filamentary. So it all fits the electrical model.
Right.
And when you come back to Venus and that, the ejection of matter from a star or a gas giant or anything like that will come from within the body, so that you'll get the heavy elements. And it's interesting from that point of view that it was only a year or so ago that it was discovered that a supernova seemed to have turned itself inside out. And the scientists were puzzled, why are we seeing these heavy elements first? And the reason is that a supernova is a really catastrophic electrical event for a star. This is what happens. The interior of the star gets shot out. And that's why you see the heavy elements first. These supernova explosions are where the star lights up and as bright as the rest of the galaxy for a short time, is due to the fact that the circuit is suddenly broken near the surface of the star, or even in some layers below. And this is an effect that you see on Earth in those high voltage transcontinental power switching yards. If you open the circuit while it's live, all of the energy stored over those 100 miles or several hundred miles of wire, the energy stored electromagnetically around the wire all collapses down on the point where the circuit was broken, and you get that colossal arc that spreads up into the atmosphere. Well, you can imagine a star, if it breaks the circuit, what happens to it? That's exactly what a supernova is.
Interesting. Now, you had mentioned material radiating away, and I've heard you say something to the effect that inside a planet, gravity could actually be repulsive, and that's kind of an interesting possibility. How is that scientifically feasible?
This is one of those problems where scientists repeatedly, for thousands of years, have used a Earth-centric view. First of all, the Earth was the centre of the universe, and later on it was demoted. But we still have this tendency to see things from our little cocoon in the atmosphere on the surface of the Earth.
Right.
And, of course, it's obvious that everything that we let go of falls to the Earth. This comes down to the structure of matter, the structure of atoms. And the electric universe also notes that there is a tendency on the part of nature to repeat patterns at different scales. Now, at the scale of the atom, if you just suggest, and this is what Velikovsky was hinting at, although he didn't get quite that far, if you suggest that the particles that make up the atom are themselves little orbital systems, then they too can distort and form little electric dipoles. And, of course, in the case of a large body like the Earth, every atom in the Earth and in us is attracted towards the centre of the Earth, or the centre of mass. Mm-hmm. And because the nucleus in each atom is anywhere from 2,000 to 4,000 times heavier than the electrons that are flying around it, the nucleus of each atom is actually offset from the centre. Now, when you do that, as I said before, each atom becomes a tiny electric dipole. But that electric field within the atom distorts the particles themselves. And that's the important part. It's not the atom so much as the particles within it that get distorted. And the distortion is minuscule. It's tiny. In fact, it's so tiny that the gravitational force is 39 powers of 10 less than the plain electric force. And this has been a puzzle. Why is gravity such a weak force? Well, this is the answer. We're dealing with the actual electrons and protons and neutrons that make up the atom in this effect. Now, when you look at it that way, you realise that, hang on a minute, we're all attracted like a daisy chain effect, like a whole string of magnets. You jostle them on a slippery surface and they'll all join, head to tail, head to tail, head to tail. And this is exactly what the effect of gravity is. All of the atoms in the Earth and in us are aligned in the same way, and so we're attracted very weakly to each other. But this suggests it's a dipole force. It's the same as a magnet. You've got a plus and a minus, or a north and a south. And that means that in the case of bodies, celestial bodies, stars, planets, asteroids, comets, moons, you have one pole facing outwards, and it's the same pole in every body. And on the inside of the body is the opposite pole, which is resisting compression by gravity. It suggests that you can actually have hollow celestial bodies.
Very interesting.
Yes. I'm actually working on this topic with some other scientists to try and figure out what the magnitude of the effect is, what the possibilities are as concerning the structure of the Earth and the Sun, because it means that you do not have infinite compression from gravity, which is required by the Big Bang model to make black holes and neutron stars and all the other exotic ideas they've come up with in an effort to create a lot of mass in a very small space. As I said before, the plasma cosmologists got rid of that necessity. The electric universe points out that it's an impossibility. It takes you back to the kind of science that engineers like, because they can see how it works.
Yeah. Yeah, that's really awesome that you're diving into that. And I know you're probably more on top of this than most people, but I've heard you reference some of the semi-recent seismic data on the Earth. What does the latest seismic data show?
Well, that's just something that I've begun investigating. I'm not in a position to make any bold statements about it.
Fair.
It's just that the centre of the Earth, or the deep seismic signals that are supposed to approach the centre of the Earth, do show anomalies, and I would expect that. But I haven't gone into it enough to be able to explain it just yet and be confident of the explanation. But certainly this has to be looked at from a completely different point of view. The idea that the matter inside the Earth is super compressed, all the geological laboratories who use these diamond anvils and that to recreate the conditions inside the Earth are actually mistaken. This view of gravity has a tremendous impact on our thinking about the rest of the universe.
Yes.
And that ties in with the work of the modern-day Galileo. He was dubbed Halton Arp, who also came to the conclusion that gravity on a galactic scale and interstellar scale must be repulsive, not attractive. And that is a rather heretical idea until you look back and you see that in history, even Newton considered the idea. There was a chap who was contemporary who came up with it, Nicolas Fagio de Douillet, who you never hear of. Then a later chap, a Frenchman, Lesage, came up with a similar idea. But in each case, they were looking at something, particles of something impinging from all directions. And when you have two bodies shielding one another by being close together from particles from a certain direction, it gave the effect of holding them in place, even though they were repelling one another. So, this is important,
right.
Fundamentally important from the view of cosmology, because when you think about it, the Big Bang is essentially completely unbalanced. You've got an explosion, and then you've got collapses and collisions. That's all they've got to work with. But what Halton Arp's work showed is that the universe is not expanding, and he showed that definitively. And so he said there must be something that holds these bodies, the galaxies and stars, apart. So he was looking into this problem, the Sage-type gravity, as it was called, repulsive gravity. But there was no satisfactory answer until the electric universe model suggests that it is repulsive. So gravity is long-range repulsive, short-range attractive. If you're close to a body, all of the atoms in your body respond to that body and are attracted to it. Mm-hmm. But once you get beyond the sphere of influence of that body, then you are being repelled by everything else. It gives you an idea that the sorts of things that Velikovsky was suggesting happened in the solar system, which under Newton's theory, of course, seemed impossible, are actually possible. Bodies don't collide with one another. They try and avoid one another, which means that it changes the whole game and raises the odds in Velikovsky's favour by an enormous amount.
Right. Well summarized. And let's get into some of those radical changes that may have taken place in our own solar system as a guideline for some of this. I guess the cliff notes of our solar system history is that initially the Earth and Mars were rotating around Saturn. The system changed spectacularly when it encountered the sun. And then we have that axial column of satellites that was formed that's kind of described in Thunderbolts of the Gods. I guess you've also described it in a previous presentation as a kebab kind of setup.
That's right, it's just kebab.
I like that visualization. But how did we get from there to here? Because it seems like such a radical change. It's probably pretty extreme and hard to fathom for a lot of people who are used to thinking about things conventionally.
Yes.
Can you walk us through how we got from a situation where Earth and Mars were rotating around Saturn to this shish kebab-like configuration?
Okay. My view is that we were satellites of a brown dwarf star. Now, in recent years, astronomers have come around to the idea that life is possibly more likely around brown dwarf stars, planets orbiting very closely to a brown dwarf star. This appears to have been the case according to all of the information we can glean from the most ancient recollections, the stories of the purple dawn of creation and so on. In other words, the light in the sky was different. And this is precisely the colour I would expect if we had been a satellite of a brown dwarf. The other thing is that the electrical model of stars, which encompasses all stars without exception, shows that red stars are stars that are having difficulty collecting enough charge from their surroundings. And what happens in a plasma then is that the electrode, the anode in this case, the star, expands its sphere of influence, and it appears as a red glowing shell, because what happens is the electrons involved are accelerated in this electric field. The bigger the shell, the stronger the electric field, and the more this glow occurs. Now, that glow would occur kind of at the boundaries of what we call the magnetosphere, or astronomers call the magnetosphere, which is actually an electrical plasma sheath within which the magnetic field of the object is trapped. Now, with a red star or a brown dwarf star, it's actually quite huge. For instance, if Jupiter's magnetosphere was lit up, it would appear the size of the full moon in the sky at opposition, and yet it's so distant and just looks like a point of light to the naked eye. But it would appear as big as the moon, or as big as the sun, if you like.
Mm-hmm.
Now, if you were to look at Jupiter then, all of its inner moons and so on would be orbiting within that glow. And this appears to be exactly where we and Mars were, plus a whole lot of other satellites, presumably like Titan and so on.
Right.
Now, when I came across that idea, it also occurred to me that this is the most hospitable circumstance you could imagine for life to form in the universe, because it's like a cocoon or a womb. Any body orbiting within that glow would receive the same amount of energy per square metre over the entire surface of the planet. And this explains why it is that we had coal and dinosaurs and so on living in the Antarctic and the Arctic Circle. This is impossible, in our present circumstance. The work of Eduardo Cardona showed that this was, it fitted precisely with this kind of story. Now, the problem is, of course, that a star which has this large glowing envelope, electrical envelope, when it meets a more bright star like the Sun and enters its heliosphere, which is its electrical boundary, then all hell breaks loose, because suddenly the star no longer has this sheath, so any planets inside would suddenly view the rest of the universe for the first time. Also, the star itself would try and readjust to its new situation by ejecting matter, and that's precisely what it did. And in doing so, it lit up phenomenally. It turned into a nova, what's known as a nova, a star that suddenly brightens by many orders of magnitude. So that's what gave rise to the stories of, let there be light. That was the creation of our new celestial system. Now, the other thing is, too, that in the Sun's environment, the star, the brown dwarf star, switches from being a star to being a comet. And we know that comets have what's called non-gravitational accelerations, and that's due to the fact that its mass is changing as a result of the exchange of charge. And it also occurred on the Earth too. The gravity of the Earth changed. But it then gets sort of sucked, if you like a pip from the centre of its little system, and its satellites are left trailing behind, rather like the breakup of Comet Shoemaker-Levy 9, where that formed a string of objects.
Okay.
But we were sitting in the tail of this comet, and that was an electrical discharge effect, and that gave rise to all of the fantastic imagery comes down to us from rock art and so on, which looked like aliens or strange, inexplicable artwork. Mm-hmm. They were attempts to inscribe in rock, in the most difficult way you can imagine, what they were seeing in the sky as being something phenomenal and never to occur again. That was the real creation story. It had nothing to do with the creation of the universe. That's a nonsense.
Right.
It had to do with the creation of a completely new environment. Now, the adjustment on the part of what we call proto-Saturn was to eject Venus, and that was witnessed, and it was described. Exactly what you'd expect. It was the worm Ouroboros, the one that the snake that swallowed its tail. In other words, it formed a ring of matter around Saturn to begin with. But it too fell behind and then became this radiating star that David talks about, David Talbot, in his work. And Mars, of course, was between us and this fantastic apparition of Venus. And poor old Mars, unfortunately, was like a bobbing object exchanging charge between us and Venus, because it would get close to Venus and there'd be this almighty thunderbolt of the gods, and Mars would change mass and drop towards the Earth, and then it would zap the Earth, and they'd move apart again. It would oscillate up and down the column, and gave rise to all of the stories of dwarves and, the mother goddess and the baby returning to the womb, all sorts of things like that. All of the inexplicable stories, but they are global.
Right.
The Australian Aborigines, in fact, here have some remarkable creation stories which describe the time when there were two suns in the sky, a greater and a lesser sun, and one of them hid in a hollow log, which was the imagery of the plasma column between us and proto-Saturn.
Wow.
There's the other aspect of this too. One of the big puzzles when we talk about the formation of the planets is Earth's water. Where did it all come from? Mm-hmm. Well, the answer is that as a satellite of a dwarf star, it is both the best place to form life, but it is also the place where unfortunate outbursts can occur on the part of your mother sun, if you like, because brown dwarfs are known to flare, and in flaring they, of course, are ejecting matter. And so you look at all the bodies in the solar system that have been investigated so far, they all have strata. They have layer upon layer upon layer of material. So the Earth and the other objects tend to have been built up. The surface layers are built up by events that occur, and some of them are quite catastrophic. And, of course, our geological record shows that we've had events in the past where most of the life on Earth was wiped out. And there's no good answer to that. I mean, the only answer that the gravitational theorists can have is one of collision. The problem there is, and they talk about the dinosaurs having been wiped out by a collision, it's not sufficient, because dinosaurs today could not exist. They could not lift themselves off the ground. They're just too heavy.
Right.
Just engineering-wise, the ones with long necks wouldn't be able to lift their necks, because even a steel girder with the weight that they had in that neck and head of theirs would bend under the weight. So the Earth's gravity changed. Now, you can't do that just by smacking things together.
Of course.
And it was fairly selective too. I think there's even talk now that the heavier ones died out first. Well, this is the kind of thing you'd expect. Also, the mega flora. I mean, we had huge trees and ferns and things at the time, and they're plants that are adapted to infrared light. So all of these things tie together. This is the reason that I'm fairly confident talking about it, even when it sounds like complete science fiction. All of these tiny aspects fit. And if anyone wants to look at the story in the detail that's required to check these things out, I recommend Eduardo Cardona's Star series, which are available on our website, of course, at thunderbolts.info.
Mm-hmm. Perfect. And that brings up a curious question, because you talk about us having memories of these massive changes in the human record. Does this model affect the way we should think about the age of things like the Earth and the solar system, the galaxy, and even the universe itself?
Absolutely. That's a good question. The radioactive dating was grasped with both hands by geologists when it became available, because it allowed them to become not just a descriptive science, but what they thought a hard science, because they could put numbers on things. But unfortunately, and this is the case when you have specialization, each group of specialists mislead the others as to the extent of their understanding and knowledge. The astronomers misled the particle physicists who looked at the half-lives of radioactive elements by saying, the solar system was 4.5 billion years old. They don't know that. That's just an estimate.
Right.
No one was there. The the particle physicists then led the geologists into thinking that their radioactive decay rates fixed. In other words, you put it in a book of standards, the half-life of this element is so many million years, without any thought to the actual mechanism, because in particle physics there is no explanation for radioactive decay. It is just a statistical thing, that's something that you work out in the laboratory and then assume that this is a universal constant. It's not. There's plenty of evidence that radioactive decay rates change. And that also comes back to another aspect of the electric universe. But then the assumption on the part of the geologists is that the astronomers told them that the solar system has been like Newtonian clockwork for billions of years. All of the bad stuff happened right up, very close to the beginning, all the collisions and accretions and all that kind of stuff, because the radioactive decay dating method relies on the Earth having been a closed system. If there's any disturbance, major disturbance to the composition of the material on the Earth, then the dating system is reset. The clock is either broken or it's, it hasn't been working for a while.
Right.
And that assumption, of course, when Velikovsky came along, his work just showed that can't be substantiated, because here is evidence of massive interference in the biosphere and of the Earth. So radioactive dating, the radiocarbon dating also makes various assumptions, so that you have to be very careful in using it. But as for the long-term dating of things like when the dinosaurs lived and so on, you can practically forget that.
Well said, man. I love it. And I guess our time is about up. Amazing stuff. There's so much more we didn't even get to. Hopefully we can do it again sometime. Of course, David is great at what he does, but